Okay, so fuel cells, secondary cells, primary cells, we're looking at all of those today in one lesson, and I want you to start thinking about how these kind of topics that we've learned separately group together. We could even group this together with combustion and burning fuels and all that stuff we did way at the beginning. So as you start your revising, which I want you to do now-ish, you've got a million things to do, but start reviewing what you've done up to this point. You should do it for all your topics and try and link them in, because you're not going to get tested on this chapter and that concept and that concept. You're going to get them all kind of merged in, and a bit of this and a bit of that, and it's all going to be in a kind of soup of chemistry. So the sooner you can start to make links, it's going to make it easier for you to remember. It's much easier for me to remember if I've got like a table of all of the concepts, or I've got some Venn diagrams and some pictures and things, than if I try and remember this bit and then that bit and then that bit and then that bit, and I might remember that bit over here, but making the link towards this bit and being able to put them together, that's what they want you to do. They want you to be able to grab everything, put it all together and say, this is why we care. If you just have them as separate concepts in your brain, it's like a different level. So to be successful in things like sciences and chemistry, you really need to be taking that, well, I know this stuff I can, in the real world would Google or read a journal or do something with. Okay, I've got these concepts. What do they mean? What can I put them together? How do they all move into one thing? So that's what you should start thinking about as you're doing some of your revision questions or watching the videos or go back through Ed Rollo. Because you would have most of the concepts apart from the food, you should be able to start to go, well, that kind of is related to that one as well. And I can see when they ask this question, they could also put some of this stuff in here, and reaction rates can go in here. And so there's making those links. So we've got some primary cells, which are non-rechargeable cells. And I had one up here. I'm tidying up. And I don't have them. So I've got just a general kind of everyday battery is several cells put together. So cells and batteries we don't ever really use cell. We use the word battery, but a battery is groups of cells put together. Cell is turning chemical energy into electrical energy. So it's taking energy, transforming from chemical to electrical, and our primary could only do this one way. So it was our general bog standard AA, AAA, whatever size battery we had, kind you might have in a remote control or something. Then we're looking at, she said another thing. She can't get the battery out. What we're looking at now is secondary cells. So these are becoming more popular. These are rechargeable batteries. So these are the ones like the Enlope ones, the ones that you can recharge, discharge, recharge, discharge. So discharge is when you're using them in your computer or your phone or any other device you might buy the little ones for. So anything you can plug in, it stores up the energy, and then you use the energy, the electrical energy, and you can keep doing that. That's going to be having a secondary cell in it. So it takes electrical energy, becomes chemical energy when I recharge it. So it's moving it to our chemical, stores it as chemical energy in my laptop or whatever. Then when I use it, it goes back to my electrical energy. We can then think of other types of energy it goes on. That's more physics than chemistry, but it goes off to light energy and sound energy and blah, blah, blah. Right, but we've got these two things happening, and we can switch backwards and forwards and backwards and forwards. So first we are going to discharge. I can't draw on the whiteboard, so I decided to do it this way. Right, so discharging. So this is when we're using it. Means generally we got the electrons flowing out. It's probably the easiest, but we've got that flow of electrons that are going, so they can be moved through something. So they're moving out of my battery through my computer and back round again. They're not just sitting there. There's this flow of electrons. So I've got discharging. So discharging means there's discharging means those electrons are kind of going out into the world to have adventures. So what's happening is I've got my cathode. I'm going the wrong way. Okay. My cathode is where the reduction is happening. My anode is where the oxidation is happening. I've got the anions moving this way, cations moving this way, just kind of being forced around. So that's what's happening when I'm using my computer. Then eventually we could have this build up. You can get a build up, like think about our galvanic cells, you can get a build up of things on our two anode and cathode. We could get a build up of metals, metal ions, we could get maybe a mixture, a little compound could be on here, kind of gumming it up. Then I've used it enough, my computer's shouting at me normally when I'm trying to teach year 7s, I can't find my cord, so now I need to recharge. So recharging is I'm putting energy in, so these electrons are kind of flowing in, making my electrical energy into chemical energy. The electron flow is going the other way. I've got the cathode where the reduction is happening, anode where oxidation is happening, and we've got the movement going the other way. If we had a build up of something around these two, it's going to break down and go back into my solution. A very simple way of thinking about it. So that's what's happening in your laptop or your phone. This is a very simple idea, but the idea is not that you know the most about a battery. You don't need to know a specific type, you need to know the theory behind it. So I will read what it says in JAC+. Some examples of secondary cells are provided in this topic, and I'll provide some videos. So they are not required to know the details of the specific cell. You should examine these examples and make sure you understand the principles. It is expected you to be able to apply the principles rather than just revisit facts. So you need to be able to apply the principles, and they're giving you examples so you can then apply it. So the example I quite like, so there's in the book, and I'll give you a link to a proper diagram thing of it that's better than mine, is the lead batteries, the ones we have in cars and buses and trucks and all that kind of thing. The one you might have seen parents take out, have to replace. I'm going to go with the nickel metal hydride because it's a good example and I don't have to do as much work. So this is like our the ones that we would have, you know, those little battery ones, little kind of square ones you might have in a phone, or you might put in a camera or something like that. They're generally these nickel metal hydride. You don't need to know what the metal is. You do not need to know huge amounts of detail. You don't need to know what it looks like. You just need to think about why we use them and the advantages, disadvantages. So advantages and disadvantages are always a good thing to think about because it helps us put it into the world. I hadn't thought this through. I think right, advantages of this nickel metal hydride over previous versions of these. So this is very wonky. So they are safe for the environment. Oh. No cadmium. So cadmium is a heavy metal, pretty dangerous. There's all that risk of mining, kids hitting it, things in it, you know, all the other associated risks. So the safer we can make them, the better things we can put in them that are non-toxic, the better it's going to be for everyone. Alright, so there is less memory effect. So this might be before your time. Remember, maybe it's before your time. There's, you know, you have to discharge your phone before you can charge it. You can't charge it because you'll kind of fix it. There was this memory effect. So the old nickel cadmium ones, if you only half used it and then charged it, you could kind of, let's say that's the battery, you used it, you use this much and then charged it, you could get a memory effect where it would only ever charge that much and you would not get your full amount of battery. We don't tend to have that so much anymore. You can, if you like really mess around with it, tell it, but it's not really a thing we concern ourselves with anymore. If your phone goes down, you can just charge it whenever. There's no kind of thing. These ones charge quicker. That's important. You know, when I have to wait ages to charge things, it's really annoying. And more charge program. Again, this is me being an old person who you might not remember, but if you watch any of the old 90s shows, maybe early 2000s, you'll see the laptops, not only was it due to the technology, but very often they were like really thick and chunky and heavy, and that was very often just due to this battery. So the battery would be really heavy and it would make your laptop like a huge, great chunky thing. Now we've got more charge per gram, so we can get more energy per gram. It means we can get much lighter batteries. We can have like really thin, light laptops that will provide energy for a long time. So these are some of the advantages. Work that out. You see, there's no risk of me becoming a YouTuber anytime soon. This would all be like done on a whiteboard or something fancy, wouldn't it? Disadvantages. Of my nickel metal hydride. Oh my lord. Disadvantages. So disadvantages are it can self discharge. And I read it was 1 to 3% a day. No, it was a week. I think. So self-discharge means if you just leave it alone, some of them can lose some of their energy at certain temperatures and certain things. So if you leave a certain laptop or your iPad or your computer or something and it's got some of these batteries in, it can just self-discharge. So it's giving off energy, like it's losing energy or charge at a rate of about 1 to 3% a week, depending on the temperature of the battery and, you know, all this other stuff, which is not ideal. I've paid to charge it. I want to use it. Like 3% is not nothing. And sometimes we can. And this was given in the book, and it confused me a bit, but sometimes it can be complex to reach. Oh my god, my hand ready to complex recharge. So to recharge them is quite a complex process. We've got that just simple diagram. It just happens. But we need certain equipment. We can't just recharge it. We've got to be able to plug it in properly. So that's one of my examples of my battery. So the new type of nickel metal hydride, advantages and disadvantages. Thinking of advantages and disadvantages is going to be good moving forward because it kind of puts everything in a place and gets you to talk about it in a real world rather than just here is some chemistry. So I'm going to show you the equations that's happening when I do my discharge. I don't give you recharge, but there you go. So I have my battery. Moving books. Singing a moving book song. Oh, there we go, that's better. Right, so I'm discharging right now because I am using energy to do my video, and to do that I need to be having an anode, having a cathode, and doing some oxidation and reduction. So what's happening is on my anode, yep, see that? I've got oxidation. And I'm going to change. So I have my metal hydride. I need to right. So you just use M for metal, because unless they give you a metal, which they probably aren't, but you need to understand there is a metal, and in as well as the nickel. It used to be cadmium, not anymore. Just as metal in everything I've read. It's very useful. This is a solid. It's kind of a pasty thing. And we've got OH minus, which is 8 groups. So can be at equilibrium. It's much more this way, but it does have an equilibrium thing to it. So I prefer putting this in the arrow because it is equilibrium. But some books you will see just have the arrow, but it is very much an equilibrium happening. And then what we end up with is our metal, which is a solid plus water to the liquid and a nice electron. Yep, that all balances. So that's our oxidation that's happening in the anode, which means we must be having reduction at the cathode. Again, remember, you don't have to remember these things. You just need to know the process and what's happening where. So they might give you the total reaction and you have to break it down into our smaller bits. They might give you one. They expect you to work back with the net. No, that wouldn't work. They'll give you the total and they'll ask you to work out the two separate parts from that. I'd suggest. Yeah, that seems to use this way. Again, it goes this way. Oh. I'm skipping ahead. Right, what we can now do is balance those to give us our total of what's happening overall. God, that gets really messy at the end. Stretching. So we have an MH. What do we have? That there. That there. That balances. We have that there. That there. Some water and some water. And the same amount. So we can then go, okay, we have MH. This is highly technical. It's amazing. Right. So MH, which is a solid, again, don't know what the metal is, plus NiOH, which again is a solid, this kind of pasty, solidy, gritty kind of thing. And then we end up with our metal solid. And got hydroxide. And what then happens is we can push it the other way. So by charging it, basically we're pushing it from over here back to here. So then we've just got this kind of endless loop going round and round and round. So that's batteries, secondary cells, batteries as primary and secondary cells. I'm going to make another video about fuel cells and bring it all together for you. So